Okay, so again, welcome to grade 4 measurement. We're going to be looking at area. I'll just do the land acknowledgement first. In the spirit of reconciliation, we want to acknowledge that this gathering is taking place on traditional treaty lands across the province of Alberta, home to many diverse Indigenous, Métis, and Inuit peoples. Spanning generations, acknowledgement of the land is a traditional custom of Indigenous peoples and an important part of reconciliation. It gives voice to the authentic history of the land and its original people. Honoring the land in this way acknowledges the story of the creation of this country in a way that has historically been missing. So thank you for sharing with me today. Please, because we have a very small group, and if you have, just kind of shout out if you have a question, or you can put it in the chat if you want, but if you just kind of open up your mic and just say, Betty, I have a question, that will be fine. So again, this is just to let you know that the presentation is going to take a look at the organizing idea of measurement, specifically the learning outcome. There are two clusters, an M1.1 and an M1.2, but it is the same learning outcome. They're just organized differently, and you'll see that in a minute. The outcome is students interpret and express area. We're going to be looking at some new vocabulary because there is new vocabulary that you're going to have to kind of get a handle on and an understanding of with area. We're going to look at the knowledge and understanding statements as well as the skills and procedures. What I've done today, again, if you've been to a session, I usually go through resources and show you everything that we have on the ARPDC site, and if there's something from Learn Alberta. What I've decided to do today is not to put them in the presentation, but you'll get them in the slides. So I'm going to go right into the presentation because I usually never finish. I don't think I'm going to get to the second cluster of cusps, which is estimating area. But I do have the slides for them and you will get them. So I'm probably going to stop at the end of the first cluster, which should be pretty close to the time that we should be finishing. And then you'll get the slides with the rest of it, and those statements are not too difficult to understand. But I am going to go right into it. Know that you will get any other resource. There are some resources I did include in the slides, but any other resource you'll get with the notes later on. So whenever I do my sessions, again, I try to start with the a warm-up, and this is some just to kind of get you in the mood for math, especially after a very long day of teaching for both of you, or for all of you, I should say. I just have a little, trying to look at my chat. Oh, okay. Oh, that's good. That's good. Okay, I'm glad I hope it's what you want, Lori. I hope that's what it is. So what I provide for you. So this is a which one doesn't belong. Now I'll show you in the next slides. You always will get slides with the sites in them. And actually these slides with sites today are not even finished. I've got a few more that I realized that I should have added to it. So this one, it doesn't belong to area. Yes, we can say yes, because we do have a rectangle or a square, which has an area of 9 square units. So we could talk about square units. We could talk about colors. I won't get you to respond, but you can look at them. It's a nice visual color. At the bottom, you'll see always I give the site where you can get them, and you can do this with whatever you want. And you can do the areas of the different colors or how many there are of each color. It's up to you. And that's a good one to get the kids going, and it's not difficult. It's what we call, I've said in most of my sessions, one of these low entry, high ceilings, where you can go anything from color to looking at area. This is a little bit more difficult. This one comes from which one doesn't belong. And it's quite fuzzy. And it could be my laptop or my computer. It could be the way I copied it again. But this one actually deals with, now we're looking at side lengths. So we're looking at 1 centimeter, not difficult, 1 centimeter, 1 centimeter. But again, you don't even have to concern yourself with numbers with the students if you want. They could look at it visually. It would be interesting if some of them say that the bottom left one doesn't belong because the other ones are 1/4 of the whole square or the whole rectangle, and the bottom left one is not. But you've got that notion of one is divided into two parts, one of the green shaded parts, whereas the other ones are whole. So again, just another one for you to do, but it's there so that I encourage you to go to the website, which one doesn't belong, which I'm sure you have, and look at the various, this one was under geometry, and you don't even have to do area. There's some really great ones there. Okay, these are the sites. Oops, I have to take this one off. I've added some Halloween sites because Halloween is over. So you won't get those, but these are I've got two sets here of slides, and I'm going to be adding more. The one in particular that I'm adding are the ones that I'm going to add are the virtual ones, because there are some where you have the grids where you can start looking at area and doing shapes and coloring. I'm going to tell you right now, nothing beats the good old grid paper, though, for the students, because you want them to draw, to color, to count, to make rectangles, to make squares, and nothing is better than grid paper. So if you haven't got it yet, and you haven't started area, I would definitely get grid paper. There's actually grid paper scribblers you can get, and if you have a dollar store near where you live, they have grid paper. Dollarama. Not the Dollar Tree, but Dollarama has grid paper pads so that you can just pull them off for the kids as they need it. So that's really good to work with. Okay, so what I'm going to give you is just an overview. So this is a chart. This is just the overview, just the keywords. I kind of wanted you to see kind of in a nutshell, because it really helps me when I teach, if I have a sense of the bigger picture, so to speak, of what I'm going to be doing in this particular series of lessons or unit or topic or whatever you want to call it, concept of area. And so you see that there are two sides, and we're going to go into the actual cusps, the statements themselves, but just so that you have that overview, that the left side, or when you're looking at it, the left side, we're going to be looking at measuring area, and we might use the word calculate because you're going to be doing in grade 4. They are going to be multiplying as a product, you can see here below. So we're looking at measuring area, and this is where we're actually looking at the actual area. And then the other side, the second set of cusps or statements, or looking at estimating area. And that's where we're looking at reference, which we call, kind of guessing. What's something that I can use to kind of estimate the area of this particular rectangle? Know that in grade 4, the students are only kind of mandated, but they do have to know rectangles, squares, which include squares. Now, of course, you're going to go, because there's so many cool things to do with area and shapes, pentaminos, and looking at, especially on grid paper, where you just count the squares, and you have 8 square units that look like a rectangle and 8 square units that may look like something else. And students really enjoy those, and you'll probably want to do those with your students, but know that they must be assessed on actually measuring and therefore calculating when given the side lengths of a rectangle or square. So we're looking at measuring the area. Tiling, we're looking at use it through the process of tiling. And for me, when we get to it, I'm going to explain that to you. That's what you're going to use so that the students understand what area is. I know it's covering something, and they have a good sense of what it is, as opposed to perimeter. But this notion of tiling and iteration on the other side, where you see estimation, we'll talk about that. And then they're looking at units. And in grade 4, we're looking at square units. And then we're going to go from non-standard units to standard units, which we're going to call square units. And then we're going to go to actually square centimeters. And we'll show you in a future slide, but I'll say it here, that the grade 4s in the new curriculum, the notation of square centimeters with the exponent 2 is not there. It is in the grade 5 curriculum. So you're going to see my slides will always say square, the words square centimeters, because that's the way it is in the curriculum. And then you're going to be looking at the students, and you are going to be looking at calculating area. as a product, which of the two side lengths. And again, you'll notice in grade 4, we are only going to talk about length. I will mention, and we'll have a little discussion on width and length, but really it's just going to be side lengths. And we'll talk about how we don't want to confuse the students at this point. And then the second set is that you're going to do estimation. And estimating, we'll be looking at a referent, what's something that I can use, as I just mentioned. We're going to look at iteration, where you only have one of them and you just keep moving that one around until you get a sense of what the area is, and then combining partial products. So when that's like when you have a composite or a rectangle on a rectangle, let's say, or a large rectangle, that's lots of that where the area, and there are a lot of squares where you can break that up into smaller areas. So here's the first set of clusters, with the cusps, and we have our knowledge, understanding, and skills and procedures. I'm going to show it to you now. There isn't, most of it is really understandable. And tiling is where, when it talks about what tiling is, and when you look at it visually, it's very easy to understand, and you won't have any trouble explaining it to your students. Tiling and iteration are, the explanations are really good. And I do want to say that as I get into this new curriculum more and more, I am a former Alberta Learning employee. I quite like the statements, because it, like this first statement, tiling is a process of measuring an area with many copies of a unit without gaps or overlaps. So when I see that visual, it's a good statement for me to know what tiling is, and therefore I can transfer that learning to the students. So this is what, because I'm going to go to the next slide and we're going to look at it a little deeper. In the next slide, what I did was highlight all of the vocabulary. And these are like the nouns, the concepts, we might say, the understanding, the terms that you and the student are going to have to be able to have some sense of. And maybe the student won't be able to verbalize some of the words that are here, but they have to have that kind of conceptual understanding. And if, again, for those of you, I hate to repeat myself, who have not been to a session, these sessions that I do are mainly for you, the teacher, to understand the math. We started to do them in 2 parts, and we usually have, the first one starts with me, and my job is to talk to you about the actual statements and what they mean, and so that you have a really good intuitive understanding of the math behind those statements, and hopefully make it easier for you then to work with the students to get for their learning, so that they have a better understanding. The second session is usually where we get into things like strategies, games, although I'm going to be showing you some activities today. I found some very good ones, and they are from some of the sites that we use, the ARPDC being one of them. So I am going to share them with you, because I think if you're going to start right away, these are easy ones for you to do. The second session, for the one where we're looking more at maybe activities and games, or suggestions or strategies, is at the end of November. So, but if you come away today understanding the math behind this, I think that you probably could think of a dozen things to do with the kids and have no problem with it. So in again, the yellow highlighted, we're looking at words like tiling. I will give you a visual for that. Area, of course. What is a unit? A square, what's a unit? One, and a square unit. Non-standard units and standard units. So students are and we've done that before. It's already been done with length. The great thing about area, or one of the positive things about area, is that the students have come with some understanding of already a non-standard unit and a standard unit for length, and a tiling and iteration for length. If they have come from that, that's going to help you tremendously. It is from grade 2. So if the grade 3 teacher didn't have the time to go back, then they not come with that knowledge of what those 2 words mean, but you'll see it. Rectangle, they have to know which is a square, and that comes from geometry. They've worked with that. They're going to look at the product. and they're going to look at the perpendicular side lengths. So the area is going to be, it's no formula, it's the product of the perpendicular side lengths. Now we could say it's the product of length times length. You can say that, but again, we'll look at it. We're looking at length right now. And if you're going to bring in the word width, it's going to have to be it. I would recommend that you bring it in a bit later. Right now, we're just looking at length times length. Then we're looking at two-dimensional space because that's what area is, as opposed to three-dimensional, something that's flat, a region, an area. And this is the statement that caused me all my grief. Area may be interpreted as a result of motion of a length. And if any of you here now have a really good grasp of that, just throw it in the chat for me. And that's the one that I went and I haven't heard back from Alberta Learning. I called math consultant colleagues of mine, and I think I understand what it means. I'm going to show it to you, and then you might come away with, well, I can show it to my students, but I need to move on to the more important things. Then we look at an area remains the same when it's decomposed or rearranged. So we've got words there, equal size unit. And you can see that I've highlighted where it repeats, because you can see non-standard units. That initially is going to be something really important. And then we've got standard units moving into square centimeters. So non-standard, standard units, and then square centimeters. So we've got those, and those are going to be very, very important. And then multiplication and looking at problems. So these are the concepts, or the nouns, the verb, not the verbs, the terms. And now we're going to look at the verbs. So now we've got this interpret, which is again a very big word for looking at. And really, to me, if students interpret and express area, if they really understand it, they would be able to see area in many different ways and show it. They have to model area. They have to recognize the rearrangement of area in First Nations, Métis, or Inuit designs. I've got a resource that I'm going to show you, and I've got some visuals for you. They're going to compare non-standard units. Which one is the one I should use? Measure, visualize, determine the area of a rectangle using multiplication. And that comes from that statement: the area of the rectangle equals the product of the perpendicular sides, versus the parallel, because they're going to be doing that in geometry as well, and then solve problems. So this is basically what that first cluster, and that's probably the thrust of what you'll be doing with grade 4 area. And this is the second set, or the second cluster of cusps. And here's where we're looking at estimating with area. So I'll go back to that one. Area can be estimated using a referent. That means some kind of something visual that I can say, well, it's about this many, and I can use it to identify about what the area is. And then area can be estimated when less accuracy is required. And then the students are going to have to be able to identify what's something that I can use, what's a reference for a square centimeter. I've got a few pictures there. If we don't get to it today, you'll get the slides where I looked and said, what could be something that they would have that they could use for an area if they didn't have anything to measure with, anything. And then estimate again. So that's the thrust of the second one. Whoops. I went the wrong way. This is the visual just to show you where these students, the learning is coming from, and how it goes all the way back to grade 2. So when we look at this overview, I'll only probably go just a little bit past grade 4 into grade 5. The focus for grade 2 and 3 is length. So that's what they worked on. And then the students in grade 4 are going to be working with length, with side lengths. So they've got a line in grade 2 or a distance, but we'll talk about lines because we're just talking about shapes. So a line, and then we're going to move that into the 2 lines that are perpendicular, or the lines, which are now going to be called sides of our rectangle. In grade 2, they look at tiling and iteration related to length. So in grade 2, they took a little a little cube or a little one of those square centimeter little squares, red and white two-sided counters, and they drew a line, or the teacher drew a line, and they just lined up the tiles one after the other and said, this is this many tiles long or this many cubes long. And then eventually it would be a centimeter, whatever they were measuring with, but they did do that. And iteration, they might have used their fingers and walked along the line to see how many fingers long the line was. It would be wonderful if the grade threes that you have now have had some sense of this, but you can see that wasn't part of grade three. So then we moved to tiling and iteration in relation to area. So you may have to do, and I do have a slide for length, just to kind of give you a prompt to see if you might want to do some prior learning with this, and then moving into area. And again, grade two, looking at non-standard, standard units. Your grade threes that have come to you, they've also come from the previous program of studies. Well, they worked with the new one, so they did have not non-standard and standard units. The interesting thing is you're not going to be working with this in area, but the grade threes coming you have now in grade four did work with the metric and the imperial system. So grade threes that you have had some work, some understanding, a little bit of knowledge. It was very hard for all of the teachers, all of you, to try to catch up to those prior learnings. So they may have been exposed to it a little bit, but it was only to relate, like, how big is a centimeter compared to an inch? Well, how big is an inch? And that's where the reference come in. Well, it's about maybe the width of my thumb, or from my knuckle to the top of my thumb. I can't remember which one it is. So I have some kind of a reference for that. And maybe a meter is as long as my arm, or an adult's arm. And is that about the same as a yard? And they may have looked at a meter stick and a yard stick. But so it was only to relate the two. There was no conversion, no changing, nothing like that. And then both of them, the grade twos were working with reference for centimeter, which is like the width of their thumb, or whatever it could be. This was for length. And then the grade threes were looking at reference for centimeter and meter. And now in grade 3 or 4, you're going to be looking at reference for centimeter squared. Now you can see I put the notation there, a centimeter squared, but that, and then for grade 5, but that was just to put it for this slide. I'm going to let you make that decision, whether you feel your students are ready for this notation, but because it wasn't in the curriculum, you could put SQ, CM for square centimeters, or you could show them the notation, but just make sure they understand square centimeters first. And that's what they're going to have the references for that. So we're going from a length to now a region. And then again, the grade 3s we're looking at estimating length, and now we're going to look at estimating area. So you can see that flow or that progression. Grade 5s, after the rectangle, they're going to relate perimeter and area together. And that's where when we increase the area, how does it change this, or one side length? How does it change the area? How does it change the perimeter when we double it, and so on? And that was in the previous program of studies as well. And then in grade 6, they look at the area of the parallelogram and the triangle. So just so that just so that you get that sense of what that flow is, and you'll get this chart. I just have to show you this document. This is the document for the verbs for all the skills and procedures. You have that. When you click on that that file or that link, you'll come up with a glossary, which is the glossary for all the verbs for skills and procedures for grades 4 to 6. And then there are the cards, these cards that give a little bit of a further explanation, and some of the verbs even have illustrative examples. And when you get to this link, it'll take you into a Google Drive with 3 folders that will say glossary. And I think one says cards, and then the other one says exemplars, or I'm not sure what the headings are, but there will be 3 folders where you'll be able to go in, and it will help you a little bit more with the verbs. And you can even use these if you're going to use words like model or visualize, a measure. You might want to take these cards, put them on use them as an anchor chart, where if you have a math part, any room in your room any room in your classroom for math, a math wall. An anchor chart is usually, it could be a term with examples, words, definitions, always visuals as much as you can. And you may want to have those there so the students understand what to do. Okay, we're going to look at area now, just the basics, and then we're going to move on to what some of these terms mean. What you'll see on the slide is, as much as possible, what I try to do is take one of the statements and always apply it to the slide. So sometimes what I did, if I knew that it was important to do a review of what area is for you, and so then what I do is I relate it to one of the statements. And you'll see that as we go along, each one of the slides will have a reference to one of the CUSP statements, including the skills and procedures. So this definition area, again, if you haven't come to my sessions, this comes from this particular site called this one is from Granite and Splash and Learn, which is on the bottom of the slide. I use two definitions here. I like the Granite one. It's American. You have to be careful. You won't necessarily find it in your grade that you're teaching. You might have to search around a little bit, but it is quite extensive and very, very visual. So this tells you what the definition of or the meaning of area is, and it goes by the multiplication of the two sides. So it's the inside boundary, and all you need to know the difference here, and that's important for the students, that it's the inside, the space inside the boundary or perimeter, inside the perimeter, the space inside of a closed shape. And that's really important that they know that. So I just put these two shapes here for you, the closed shape and the open shape. So it has to be a closed shape. And it's 2D, it's flat. That's very important for them. And what you need to be aware of, if you're going to use pattern blocks, or if you're going to use cubolinks, and which is a great manipulative to use, and you put them together, and so they make rectangles, or with, but that with an area of 12, 4 by 3, 6 by 2, or whatever, and use different colors to show them that it's the same area, but it's different shapes. If you do that, that's great, but you just be very careful that for some students that is three-dimensional. And so that it's the top of the array of cubolinks that you're looking at. Most of the students get it because that's all they look at, but just so that you're aware that there is some height to those cubolinks, but that's great for when you get to volume. So really, when it works great for surface area, because if you use that as area, then when we get into surface area and volume, it works really well. But just be aware that some students might be kind of looking at that height. Not very many, but cubolinks is good. You want the pattern blocks is the same. If you do area with pattern blocks, make sure we're looking at the top. It's no different if we look at the top of a desk or a table. That's you're probably by right now. We're only looking at the area of the top of the table. So it's two-dimensional, and that's really really important. For those of you who've taught for a while, we in our previous program of studies, we said 2D shapes and 3D objects. Now everything is 2 and 3D shape. So you won't see the word object in geometry, not at the elementary level anyway. And then areas measured in square units. And that's where we get to that non-standard units to a square unit to then centimeter and meter and kilometers squared. And this was the understanding. Area is a measurable attribute. An attribute is something that belongs to a group. In this case, all 2D shapes have area, and that's an attribute. But a property of a rectangle is that the area is the length times the width, or the length times the length. So, but an area is an attribute, and all 2D shapes will have that particular attribute, and it's the amount of two-dimensional space contained within a region. This is just to show you, these are all 2D shapes. You can see this one is not a rectangle. Lots of the other ones are not rectangles. Some of them are not even what some of them are regular polygons. Some of them are irregular polygons. But this is just to show you that all of those indicate that that's area. And I think that's important for students to see. We don't want them to just know that it's rectangle. That's what they're going to be working with, but that anything, any enclosed region is an area, and walk around and get them to touch and feel and say, oh, this is an area, as opposed to height or length, or how long something is. So and looking at a seat of a chair, at the floor, how much floor is covered, how much what a rug, the area of the rug, how much space there is. Those are the kinds of things all everywhere that they're going to look at and see what area is. And here's some examples. So we have the rug, the floor. It's that space between the walls. That you can see the rug here. That area, that surface part of the rug. A backyard, the seat of a chair, the table, the desks that you have here. And I tried to get something big, like a soccer field, the field outside. So if they walk around the field, or if you get your students, let's say, to form a rectangle, and it could even be a circle if you wanted, but even a rectangle around a part of the schoolyard or the gym, that floor and that grass, which may be snow soon enough, it's everything that is in the middle of this, around them, in that center is the area. I may not be saying it the right words, but you'll see, you get the visual for it. Even their little mini whiteboards, if they have little mini whiteboards, that little surface area, that the surface of that little mini whiteboard, that's area. And if you do have mini whiteboards, if you use paper with the page protector, that's a great one to tile for the students so that they can see the area of that, because that's a really small one. Okay, so we're going to look at the unit, which can be chosen based on the area to be measured. So right now we're not necessarily looking at square units. We're looking at a unit that's going to measure area. And then the understanding is an area is measured with equal size units that themselves have area. So each little unit that I have is in itself an area, which leads to, again, it's going to lead to that one little square unit that we have is 1 square centimeter. And that's the area of that little square. And they don't need to resemble the region being measured. So I'll just show you what that looks like. This is very simple. I use squares mostly, or something close to squares. So here we have something called units, and each one of those little squares, I could use anything. I have a small square, that's what that's supposed to be. And so I'm going to use small units. And I just called those units at this point because they're not necessarily square, and I don't want to mention that they're going to be square units at this time. But eventually, I'm going to be calling those units square centimeters. So they're standard unit when they become a standard unit, and I use only the square centimeter all the time, consistently with measuring the area, then they're going to be called square centimeters. Your grade 4s are only working with square centimeters. But if I have something large, like try to visualize that being a large field, then I'm going to, or maybe a large part of the floor in the classroom. And that's where those of us who've taught for a while, we used to take our 8.5 by 11 paper and we cover whatever that big area was in the gym. Or I used to get the students to estimate how many of those 8.5 by 11 papers would cover a certain part of the gym. I think almost took a quarter of the gym. So they had to estimate first and then cover that, try to getting them to cover one row and see if they could figure it out how many, if there was maybe 10 rows or whatever. But see, I'm using bigger units because if you can visualize this, a bigger area. So, I mean, when we talk to the students, we say, if we have this little square unit eventually, or if I pull out a little square counter for them, two-sided counter, the red and white ones, and I say, like, is this something that would really be good for measuring if I was to measure the area of this floor, if we went into the gym, or if I had to measure the football field? So we're trying to get them to see the relationship between what the unit of measurement is and what they're measuring. So those are also units. You can see they're different sizes. And eventually those would become when we start to look at square meters. Now, this is to show you that the unit, it doesn't have to be square. So these triangles, because they covered it, and you're going to see that we're going to talk about being no gaps, those are also units too. So I can say that that particular rectangle is 1, 2, 3, 4, 5, 6, 7, 8, is 16 triangular units, because we don't always have squares, but you're going to work with the students because in an area there can be no gaps, but that's just another form of a unit. So now we're going to look at tiling for measurement. So this is a grade 2 knowledge statement. So tiling is the process of measuring a length by using many copies of a unit. Notice it doesn't say square unit at this point, but we are going to use the square units, the counters and the squares, because it's just so much easier. But notice it says without gaps or overlaps. So when we looked at measurement in grade 2, we drew a line, as I said, on a paper. They took I did the edge of a table, I think, with the teachers, and we took those counters, and you could use the Cubolinks if you wanted to, and we tiled. So when you tile, you just put them one after the other, and you just line them up. Now you're going to see in my pictures here, there's spaces between. I'm not the best with spatial awareness, but they should be touching each other, and you'll get the students to do that. So then we look at length, that this particular line is so many units in length, however many green ones there are, and that's what tiling is. And we get them to put that so that they can experience the tiling. They have no trouble with that. Now I'm going to go, tiling is the process of measuring an area with many copies of a unit without gaps or overlaps. Same statement as grade 2, only it says area. We'll look at this other one in a minute. So now I'm looking at area. So this is just a very simple picture to show you that these are big, that when we look at tiling, we take an area, and I'm always going to take a rectangle because we work with rectangles in grade 4. And so we take that tile and then we cover it. So this area is 8 square units, I should have said, or 8 units in this case. They're not necessarily square, so I have to say the area is 8 units. But I can use this. It doesn't, in this case, it's not square, and I can cover this area. The area is 32 units. And, I don't know, as I read this from a teacher perspective, I have to say the area is 8 units. I can't say square because, especially in the second one, it's not square. Even though I'm multiplying, these are not squares. But there are 32 of those rectangular units that make up that area. So that area is 32 of those rectangular areas, but they're the same shape. And this is the whole, the whole story, or the whole start to standard units, because I have those squares. So which one is it? That's why I have the question mark. Is that area 8 units? Or is that area 32 units? So we look at where it says measure area with non-standard units by tiling. So we're looking at these non-standard units, and the notion is to start the conversation that we need to have the standard units. There's a really excellent book, and I actually had a class do a reader's theater on it, called How Big is a Foot? And it does look, it is on lengths, but the king wants to buy a bed for his wife, and he doesn't know how big to make the bed. And it's the whole notion of going from standard units, from non-standard to standard, because every time he measures the bed, he measures it with somebody else's foot. And of course, everybody's foot is a different length. And so oftentimes the queen gets into the bed and it doesn't fit her. And so it works through that story. It's great for grade 4. It's a very, very old book, but it's really great for seeing why having a standard unit is so important. So we're looking here at tiling again. There's the definition from that site I told you about, where it shows you what tiling is. There, and it's just, you can just print that off if you want, or just copy it and put it so that the students have it. So it's that pattern of shapes. And what do you notice about it? All the shapes are the same. That's what tiling is. It has to be the same shape. And it says here to fill a plane, but that's a 2D shape. The shapes do not overlap and there are no gaps. So this is the notion of, and again, I didn't fill it, where you're looking at tiling with the same shape and it will fill. This one you have to show them because this is what you would use, that, and that shows overlap, or that shows gaps in this case. Circle is the best one to show gaps. So really, you don't get the real true area because there are gaps there. And you want to show that, and you want them to understand that it has to be, that's why we're going to go to those square units. So it says here, compare non-standard units that tile to non-standard units that do not tile. And that's a unit that doesn't tile. So now we're going to get into, we're looking at the square centimeters, and you can see it all build up. This is like repetition. So again, it's not the greatest, my alignment of my little square units, but now we're looking at the square centimeters. So we've looked at different sizes of units to tile, to measure area. And now we're going to go with the standard one that everybody knows, everybody in the classroom will use it. And so we'll be happy with that. So that's the square unit, which we're now going to call the square centimeter. And so that's the square centimeter. And now you're going to go through that process of tiling with the square centimeter and go back to that shape where I had 8 and 32 and say what it really is now. So there's it in words. And I'm using that because I mentioned about the notation. So this area is square centimeters, and this is your skills and procedures. Measure area with standard units by tiling with square centimeters. Now, if you don't have those little centimeter tiles, then you can use your unit cubes from your base 10 if you've got those, because I believe those are 1 centimeter by 1 centimeter. We're not at this point, and this session doesn't get into measurement, but once you get into without tiling and looking at side lengths, if you're going to use a measuring tool to measure the side lengths, so before you multiply, that it's not in one of the slides here, but that's something that you may wish to do, but you still need to get those, that they need to experience covering that surface. And then the note here, the note about the notation of the square centimeters, and not included, but it's until grade 5. But again, that would be something, a decision that you would make if you feel your students could use that, would be okay with that. And this is just just an illustration of those two statements. The area of a rectangle can be perceived as square-shaped units structured in a 2-dimensional array. So that's where you start, and you use your, I've got the virtual sites for you. Polypad is a really good one. Didac is a good one. Gizmos from Alberta Learning, you have free access to that. That's a good one. Those are all on your slides. I'm only going to show Polypad if there's time today, but you can go to any one of those and just put them up for the students and start creating so that they can see it. You can do it on a slide format if you want, or you actually get them to get their little squares out and start creating, or use the grid paper and get them to color. They like doing that. They have no trouble with that. But this is just to show you that this is what this statement means. It's just square units. And then visualize and model the area of various rectangles as 2-dimensional arrays of square-shaped units. And that's what it's showing here. Now, this is the statement, and I don't know if I'm going to have to stop sharing and show you what I mean by this one. This is the one. I'm going to show this to you, and then I'm going to say, maybe kind of think about it and determine how important is it going to be for your students to understand this. And, if it is really important, I apologize. It was just very difficult for me to get wrap my head around what that really meant. I had an inkling, and I was correct in my thought, but we'll look at it, and then you can determine that. So it says area may be interpreted as the result of a motion of a length. Now, it was this statement, the result of a motion of a length. So I was thinking initially it meant, oh, a square by 8 by 2, and I'm going to increase the length of that. But it says it didn't say to start with an area model. It says it's the result of the motion. So this is just a visual that I have. So this is where you start with the line, and then you extend this line to its parallel side, that we're going to go from this line to another line here at the bottom, the parallel, and in between everything becomes the area. So I'm going to show you what this looks like on polypads. It's not going to be, it won't be the full screen. I'll just go here. Oops. And I'll share my screen, and I'm going to go here, okay? Hopefully you can see this. So this is, I use polypads quite a bit. This is the, I'm going to go to the side here, and I'm going to use the grid because it was just easier for me. So I'll show you what this looks like. This is very quick, and you'll see. So, oops, I got to move this. So I'm going to move this up here so I can see this. So I go to my construction tools and Polypad. And Polypad shapes everything. And I'm going to go to a rectangle. And I'm going to draw the line. I hope this works for the rectangle. I'll go down here. Okay, now what I'm going to do is, this is a line. See, and this is what I interpreted as being the result. Area is the result of motion of length. So here's your length. And I'm going to take this and I'm going to move this down until I get a rectangle. And then I have area there. And I can do that vertically or horizontally. So it's that motion, it's the result of the motion of length. So again, this is my interpretation of it. This was a couple of math consultants' interpretation of it. One said it just meant, and it's not going to work on this one, but this way, yeah, it is. So this is what one person thought it meant this, if I just increase the length. But that means I'm starting with an area. So I'm going to go stop sharing this. I'll go back to share my screen again. And it won't take me back to where I was before, so I'll have to go down here a little bit. Here. Okay. And I'll smooth this and share this again. The full screen. Okay, so that what you just saw is what this looks like, the result of this. And the skill and procedure says model area by dragging a length using hands-on materials or digital application. So, you know, I dragged that length, and this is what we got virtually. If we were to do it by hands-on, the only thing I could think of was if you kind of had a roll of, I don't know, wax paper or foil, and you had that roll, that length of that tube, and then you started to unroll and move that foil out, you would see that by moving that length, that side length, you get an area. Again, you know, I'm not certain if this is important. I mean, it must be if it's included in the curriculum, but I'm just going to leave it at that. That's information for you. And maybe you have a different idea or can gather information. I would love it if you knew something that I could learn from. So, okay, so we'll just keep going. So we have understanding. And now this understanding is an area remains the same when decomposed or rearranged. And again, that makes sense. You understand it. They just have to experience it. This follows through. They've worked with decomposition of number. They have the number 32. If they decompose it into 30 plus 2, or they go 25 plus 7 or whatever, it's still 32 no matter what. And that's the same with area. The area will always be 20 square units. You can break it up into 10 plus 10, 5 and 5 and 5 and 5, and 4 fives, or any way you want, like looking at it like tangrams, even like puzzles. It will always be 20, and it will always be a rectangle again when you put it back together. And when you rearrange them, this one, again, this one is more breaking it apart to make it easier to do the area. So you've got 8 square units here. It's not a rectangle, but you can break it up into 2 small rectangles, which are 2 and 2 and 6 square units. It'll still be 8. And these are the ones that the kids really like, because even though that is not a rectangle, you're working with area, even though it isn't a rectangle. And they really love to make different shapes. If you said, make as many shapes as you can with 12 square units. They really love, if you give them the grid paper, they really like, because they want to make maybe a creature or something like that, or an animal or something. They love that. And I think as long as you're working with area, I think the kids would benefit from that. And then again, an area remains the same whether decomposed or rearranged. So here we have what I just mentioned. We have 8 square units this way, and we've rearranged them to look 8 square units this way. So we're looking still at rectangles, but if you do this one, it's okay. And the tangrams. Now, this is again an activity. We're looking at, and I've given you the site, Mathagon, this polypad that I just worked with. It has tangrams. You can see there's the link there. And it has shapes where the students will take these colors and they'll impose them or superimpose them, I think is the word, onto these various shapes. So this triangle is composed of all of these shapes. Now they're not to scale. Notice I said these images are not copied to scale. So this triangle looks much smaller than all of these pieces together. Or this parallelogram, or this house, which is not a geometric shape, but they all fit. All of the shapes will fit, and you can work virtually, or you can print them off if you want. If you've got, you can print off these colored ones, or just make them one color if you want into the different pieces. I'm sure you've worked with tangrams. You've read Grandfather Tang's story about tangrams, and it just illustrates an area remains the same when decomposed or rearranged. And this is just, again, another fun activity, but it just internalizes the fact that all of those shapes in that triangle will form that square, and they're exactly the same area. So now we're going to look at going into calculating. So the area of a rectangle equals the product of its perpendicular side lengths. So what does that mean? What I'm going to show you in the next 2 slides is just something that I feel is important for you to understand. Maybe, and I think intuitively you know it, but I think to see it is going to be important, because this is where, when we start to work with area of various shapes, and as the students start working with triangles and parallelograms, we always show the rectangles. They'll always look the same no matter how we place them, except if we place them on the longer side as the base, or if we place them on the shorter side as the base. But with other 2D shapes, it gets a little bit more tricky. So what I wanted to show you is perpendicular side lengths. There are 4 of them in a rectangle or square, and that's important for you to know, and it's important for the students to know, because it isn't always going to be this left side times the bottom. It's not always going to look like that. So here's the length, and here's my horizontal length, my line, and then my vertical length, my line. So these 2 are called the lengths. The side lengths, we aren't calling them width and length yet. And then I've just got this to show that they're perpendicular or right angles, and they do work with angles. But there are 4 lengths, and there are 4 perpendicular side lengths. Here are just some definitions for you. Here's what a perpendicular line is. You need to know that, and the students do, and as well as what length means. So I just did this very simply for you so that you can see that we're working with, when we the area of a rectangle, when we're looking at the product of its perpendicular side lengths, it could be these two perpendicular side lengths, these two, or these two. And I put them there because when you work with that, I would encourage you to put, if you're going to just, if you're moving beyond the tiling and now you've got it into actual numbers or digits that you're going to put, that you put them in different places and not just, this is the one here that we're most we see most often, and then maybe this one in the blue, but the green and the yellow, we don't see those that as often, or we tend not to do those because we don't want to, kind of foul up the kids. We want them to be successful, of course, but they need to see that there are 4 choices for multiplying the perpendicular side lengths. Length times length, length times length. And that's what you'll continue to do in grade 4. So, and then it says determine the area of a rectangle using multiplication. And so when they get these squares, which is exactly what they do, if you want them to note which are the perpendicular side lengths, and then they can multiply those. So that's a visual for you, and it might help you when you're working with the students. Now I want to show you this one, just a few things, and we won't get to estimation, but you will get those slides. So I'm just going to go through and finish to the end. We've worked through almost all of the first set of cusps. This one is recognize the rearrangement of area in First Nations, Métis, or Inuit design. Now, I'm not necessarily confident that I gave you visuals and ideas for the rearrangement of area, but some of the ideas came from this book, and some of them I got them from websites. So this has been updated. This is on the ARPDC resource site. It's called Infusing Indigenous Knowledge into Curriculum. And there's a section in there on math, and it's the new curriculum. And so what the author did for this is go into each of the areas of math for grade 4, we'll say, and correlated and put beside the actual set of cusps that I just spoke about, these particular activities. So recognizing area in building a hide frame for stretching, beading projects, braiding ropes. I'm not sure why I put season there, and recognize area and activities such as moose harvest, building a cabin, preparing a moose hide, and it's looking at that frame in particular, those frames where they then put the moose hide, or the frame for the drum. Now, most of the drums were circular, but it's that surface area that you're looking at. Using sinew to measure and tie in angles, some of these ideas will cross over into other learning outcomes as well, and then quilting patterns. So make sure you look at this resource and get some ideas from there for everything that you're doing within math. So here's some of the visuals. So this in particular, this comes from a site called Finesse, which is actually from BC. It's a First Nations Education Service Committee, but they have a site, and you'll get the site, and they have math. They have actually a math resource, but most of whether it's the patterning or the housing are from Indigenous peoples from BC. Some of it crosses over, some of it is very, very specific. So this one in general, so we're looking at, and again, just the notion, the story about, there's wonderful videos, the story of, building the frame, how it's done, whether it's moose or deer, wolf, and how they tie it together. It talks about angles, but just that notion of area, and again, the story behind it. This is showing you a hide and it's got the grid, so that you can do some estimating of area of that particular hide. And then again, looking at the blankets, and looking at area within. This one is from BC. This is a storybook. It's a beautiful book that goes with this, the making the blankets. So we're looking at the area of the blanket. How do they decide the length, the two side lengths of the blanket? This is just patterning. And again, you can look at area because almost you've got all of these little squares or all of these non-standard units. So what would be the area of that pattern? If you haven't done anything with symmetry is grade 5, but with geometry, if there's anything, it's great for reflections as well. And then we're looking at the homes as we saw on the previous slide. So, and again, this one said Métis and Inuit, First Nations, Métis and Inuit. So we're looking at, again, this is the circular, but we can look at the area inside. I couldn't find any floor plans of a Métis cabin. That's a Métis cabin in Alberta. They talked a lot about that, but I couldn't find any floor plans for them. So, but they could be able to construct their own. If you, whether you do it yourself or if you bring someone in, they can work with area in that way. Some of the other materials that are on the ARPDC site that I'm going to show you, this one in particular is very good. This comes from the Calgary Board of Education. What they did is they put they collected math tasks. I think they just went on the internet, or maybe they asked some teachers, and they put all these materials together depending on what the outcome is. So in this particular outcome, we're looking at grade 4 area. This page, all of these blue link are live links to activities. So these will look at any activity involving area of the rectangle. So you just have to go to the ARPDC site and look for these Calgary Board, just you could type in Calgary Board of Education, and then you can use any one of these. And so I'm going to show you a few. One of them is U cubed. This particular activity is called the fewest squares. Whoops, I'll go back. In this particular activity, they have to draw an 11 by 13 rectangle on their grid paper, and then they have to be able to find out how many squares could you make in that. So there would be all the little squares, then you could make a 2 by 2, a 3 by 3, and one of the professors said that they had their students do it, and I mean, they still didn't complete it. So it's just, I mean, they'll just keep working and working, but they'll understand area. I mean, it is going to take a long time and you may never finish. And then they understand that notion of squares, what a square is. So there's an activity. There's our tangram. It's similar to the one I showed you before, where they're going to take the pieces though and fold them and then see that they can make very many different shapes from them. But when they unfold them, they're still going to come up with this basic square. This is a different kind of a tangram. This one's only got the 3 triangles. Again, I've said this before, grid paper works. It's just perfect for everything, and they love it. There's a game that I'm going to show you in a few minutes with this. We're just almost finished. This is called Shikaku Puzzles. It's also from the Calgary Board of Education on that site. I thought it was very neat. This is a great way to practice area of square units together, like with a partner. And basically what you see this 8 here, what the students have to do is then cordon off, or with their crayon or pencil or whatever, cut shape, line up or circle an area of 8 square units, and the number has to be in that area that they follow. So it has to be sectioned into rectangles along the grid lines so that the number in each rectangle refers to the area. So, and you can't have 2 of the same numbers in one area. So this is 8, would be 8 here, and then you work, and they can work in partners. There's different ones. This is what it looks like when it's finished. So there's 5, and then on the right-hand side, you see there's 5, and then 4, and they made 4 across. And so there's going to have to be some strategy as you go along. And you can use all the grid paper you want. The students can put in the numbers that you call, and then they have to make this. And again, it's just looking at area. That's what they need. They really need to practice that area. And then you can ask them to give you the side lengths of each of those if you want. You know what the area is. What are the side lengths? And this is the game with the dice. How close to 100. There's 2 games I gave you here, where again, it's just looking at basic facts. Again, they roll the 2 dice. They come up with they have to multiply in this case, and then come up with the area. Each person has a turn. And the person who is this one is the person who's closest to filling in 100 squares is the winner. So each one has their own sheet, and you roll the dice, you make an area. If you can't make an area as it gets closer to 100, then you have to, it's the next person's turn. Now, the way I've done it with this, and I'll just go to the next one. Oops, no, it's not there. It's in one that I'm sharing with the other set of cusps. What I've done with this is let them choose. So if they want to do 3 times 1, they could do 3 plus 1. And if 3 plus 1 is 4, then they have to make me an area of 4. They can subtract, especially as they start to fill in those squares and we have little spaces in between. Maybe at that time, when there's 10 or fewer squares, empty squares left, then you can say, well, then I'll let you add and subtract as well to fill those in. So there's different ways that you can play this game. But again, it gives them area, practice their multiplication factor in this case, and they can see different configurations for the same area. This one is very, very similar, but it's called Play the Land Grab Game. It's the same thing. They're going to roll the dice and they're going to decide which is the length and which is the width, and then they're going to color them in. So, and that's on the Calgary. And then the last one, I think this one is the Oops, I Forgot, which is really cute. This one is not, I didn't get rid of some of these statements. When you start with this one, you have to hide these 4 statements that are at the bottom here. So you would just say, build me a rectangle that is not a square. So the students on their grid paper would build a rectangle that's not a square. And then you start with the next slide that says, oops, I forgot. And you just give this statement. The area needs to be 24 square units. Oh, so then now they got to go back and they've got to give you a square that's 24. The area, doesn't have to be a square, sorry. The area needs to be 24 square units. So they're going to do 8 by 3, whatever. And then, oops, I forgot, I actually need 2 rectangles. So now you're going to have to do 2 rectangles that have an area of 24 square units. And then you introduce the third one where the perimeter needs to be less than 24 units. The last one is the most difficult. You might not include the last one. I'm not sure if I would at grade 4. The length needs to be at least twice as long as the width. If you feel your students can handle it, that's great. But this is where there's lots on this site. This is Nat Banting, who's really great. When you go to this Nat Banting site, oops, I forgot, there's a wealth of other kind of activities too. And I think some of them will still include area. But this one, it's like a math talk where they start and then they have to clarify and clarify again. I've done this many times with kids. I've done the cookie one with fractions and the kids really like it. So some literature, some books about area. Circumference is always great. This one, Sam Sneaker Squares, he's going to be measuring the area of lawns, so he can determine how much he's going to get paid. And then Spaghetti and Meatballs for All, because the table configurations keep changing, and so therefore the size of the tables have to change. So that's just, and as much as possible, anything that you're going to read it, and I still, circumference and the first round table, those kids love to listen to any of the circumference books as well, but you can find them online if you haven't got them in the classroom. Just make sure if you do any online books that you always kind of preview it first, because sometimes you get a better reader than others, and you want that very clear reader that has kind of some emotion to their reading. So I'm going to stop here. You'll see that I've done the rest with the second cluster, but we've only got 4 minutes left here. So I'm going to stop there. The second cluster, the estimation, is not going to be difficult. It will just talk about iteration. So I didn't see the second session for grade 4 measurement area where it will give you strategies. But again, you have some here, the virtual, the grid paper, the activities. I'll just stop here, stop my sharing. Oh, okay. So I think I'll just go here. Right. Okay. Okay. So I'll just stay on for a few minutes here. I'll just stop the recording. I'll stay on for a few minutes here if